this is called lesson 9, which is called matrix arithmetic. Misha, did you get all that too?
Yep.
Yeah, that's awesome. I'm so happy about that. Because I didn't do that good of an introduction in my other class, so I really was hoping I could do it in this one. Let me ask you, what was the thing that we did in vector arithmetic? What was the first thing that we talked about in vector arithmetic?
Scalar vector multiplication.
What was the next thing we talked about? Vector addition. Can you guess what we're going to do in matrix arithmetic?
Matrix.
Yeah, so let's do definition. I guess I'll do it in this. I should have do this in the same order. Let's do scalar matrix arithmetic. Could you guess what I need in order to define scalar matrix arithmetic? Yep, I need a matrix and a scalar. Can you guess how big my matrix is going to be? M by n. Then, I think we did talk about entry notation in this class, right? Entry IK. Could you guess, if I multiply a scalar by a matrix, how I do that? And the way I'm going to have you guess is, when I multiply a scalar by a vector, how do I do that? I take the scalar and I multiply every single entry, every single element. How do I multiply a scalar by a matrix? Okay, so what does that mean if I take entry IK of the scalar matrix product? What would that be? It would be the scalar times the ikth entry of this one. So that would be the scalar alpha times entry ik of a, right? And another way to say that, it would be alpha times a ik. In other words, so this is if and only if, when I multiply alpha times a, you will see in this class that dots are abused. They are overpaid and underworked. No, they're not management, they're labor. They're underpaid and overworked, right? Yeah. How would I know that dot right there is a scalar matrix product?
The alpha and the scalar.
Yeah, okay. In other words, you're confirming to myself or yourself that this thing is a 1 by 1 and that's an m by n, and thus that dot cannot be an inner product, it can't be a outer product, it can't be a scalar vector multiplication, it can't be a matrix multiplication, it can't be a matrix vector multiplication, it can't be a vector matrix multiplication, it must be a scalar matrix multiplication because we confirmed the dimensions. Let's go ahead and look at that. This would be alpha times, yeah, the dots in this classroom do all of that work. So this is A12, A22, all the way down to AM2. And then we go all the way down A1n, A2n, all the way down to AMN. So this is now an m by n. What is the scalar matrix product? Should have ate some more dinner.
Alpha A11, alpha A21.
Mm-hmm. Yep. How many different multiplications are happening with that one dot?
M times n.
It's pretty cool, isn't it? That you can write one symbol on the page that represents m times n different operations. It's the most powerful operation that I don't know all of your histories with math, but if you went through the standard American education system and you don't have some compelling reason to spend hours and hours and hours doing really complex math operations, this might be the most powerful operation in terms of the number of operations that get done with one symbol on the page. So here, A2n all the way to AMN. Okay. So that's called scalar matrix multiplication.